Okay, so I was able to confirm that everything seems to work. Cool. I also corrected the link to be actually the live link, but yeah. So that is actually the live link, and another thing that comes to mind is one. Oh yeah, I also added like a bookmark for the Twitch website, and I checked if they work. So that's about it. And yeah, so I was looking at this yesterday, and I was thinking about some feature. But what was it? I guess I can add wait until, and then I guess do we need if we have async plus wait until question mark. I don't know. I know that wait until is definitely useful, so I should have it. Because not always you would actually want if ones to be non-locking. Unless I make if ones by default be locking. But I actually don't know how to do locking code on the recursive in the recursive runtime. So actually creating new scopes is just easier for me. Like that's something I can do and I know how to do, and doing waits and wait until, so just locking code, I just don't really know. So like the first three I don't really know how to do yet, and the next three I know how to. I think I would want to support all of them though, because that is just like that would just be more user friendly, right? Because yes, technically if you have async wait and wait until, then you don't need after every and if once, because you can re-implement them yourself with like a while loop and like some waits. But like you want ordinary people to be able to write this, so like every 1 second is more readable than async while through like wait 1 second, do something. Hello. I don't even know if it's the bud. I think I should support while true, just like that, without the true, right? Like just something like this would be nice. Anyways, I'm actually not doing async today, I don't think. Maybe if I have time, but I'm improving the type system, and I think I finally should finalize. So I don't want this syntax, I want this syntax. And I think I'll finally do it. I don't know what I want to do for when we have. So what JEI does is if you include this here, right? Instead it would go this way, right? But I don't know if I want to add that or no. It's definitely useful to have loops that are going down. I could also just allow implicitly. So I could just allow you to have like 10, 0, which would be 10 to 0, right? Maybe I don't even have the equals and I have it be the default, so I did this, right? But what I dislike about it is that if you have a count variable, then now you have to always do count -1, like this, right? And then if count is actually 0, then you would iterate from 0 to -1. So that's a problem. So we can't do that. I don't know. So maybe we just don't allow that, and we have this version, which goes like this. It's kind of like I would want this to be maybe like this, right? But no, that makes no sense. Because I did this, right? And then now every time the E is actually optional, so you can't just do that. Or maybe what I do is I do this, right? So I do it like this, maybe? Where I say that we are actually going the right way. It kinda looks weird, but maybe that's fine. Not sure. I don't know. This is probably better for parsing though. So this is like greater than symbol, so it says that like visually it looks like the left is greater than the right, so it's probably fine. We'll probably do that. Now do I want this to be before maybe? I don't know. Also would probably want this to be an actual assign. Although I don't know. This 4 is so convoluted. I don't know. I will not do it yet. I have to think about it for some more. But let's do more type stuff because that's something we can do. So now basically when I push the statement, right? Let's also add this. Let's also add runtime time result type, right? So I want you to be obligated to do this, right? And now what I would want is I would want runtime result of 2 times, right? A, B. And now what we have somewhere is we have this promotion bool, right? One sec. So yeah, this basically means we need to add at least implicit casting, but also the explicit casting. Let's see. AI parser, AI wait, that's in runtime, right? Oh wait, what is this? whatever. Yeah, so now... No, one sec. Oh, one another thing to note probably is after we add strong typing, we should probably add native functions instead of print keyword. Print is currently a keyword that just looks like a function, but it's not actually a native function. Okay, so now if values have types, right? Have types, and we do a, I guess this could be pointer, although I don't even know. Oh, actually, this is not useful for us. AI runtime here. And what we need is we need an equivalent, but for just types. So, so both two types or something. So AP and then 1, 2, I guess. I don't know. So now we return A equals 1 and B equals 2, right? Or B equals 1 and A equals 2. Matching pair of maps. I guess. And now what we do is we do A, B, and we do runtime type integer and runtime type decimal. And if so, we just return we just return runtime type decimal. Right? And now if A equals B, we return A, right? And otherwise we do runtime type undefined, right? thing that does it. I mean, if A equals... So for those, we actually kind of want to... Because this is kind of not true, because if we... So if we would do like a string plus other string or something weird, this is not a valid operation, so the result type should be undefined, or rather none. I don't know. Okay, so I don't know. What I could do, I guess, is I guess that makes a lot of sense. So I would do default value of A, right? Parser. I should probably take the parser instead of the arena. So let's replace this with just parser. Okay. Okay, default value. Something I'll have here. And now basically from the runtime. Okay, that's silly because actually I need to make this be. Now I need to convert back because I need to pass this something more custom. Oh, I don't know. How do I do this? I don't want to copy the switch from the evaluation. Parser. Okay, I guess this is... All I just did is wasteful because I can't even use default value. Let's keep it as it was. Okay. So maybe let's go back to what we used here. We should be more strict here. Should only allow kinds of operations that are supported if this should return type none, right? Okay. And now we have all the type problems, right? As I wanted. So now this is just integer, we know that. This we know is type none. Yeah, so this is type none. Okay, and now we have function call. Yeah. So now what we need is we need like some temp. We need a temp arena. And I guess it's just fine if we own that arena because we'll be disposing of it. So now here we would do free arena parser temp, right? Okay, and now what we need basically is we need like a kind of so what we need is we need a type scope, right? And it needs to be a list of variable type. Maybe static, I don't know. Parse and funcs. So this is just a string name, right? And it should have runtime type, right? I don't know. Alright, you should find a better name later. Result type. Okay. Okay, so now that we have a type scope, we will need to add static void declare type, declare variable type, right? Would be the variable, so it would be the type scope, right? Scope. And we would say the variable name or name, and we would declare runtime type. And this probably needs an arena marker. And maybe this is just like scope arena or something. And we have declare, we have runtime type, get variable type, and then we have the same for functions. Function, their type, and string. And declare variable type is just scope. So how to do this now so it's not actually a problem? Yeah, I know what it is. I will use variable type pointer and function type pointer. And now I would do for scope first run. Say variable type equals this var equals var. Of course, this needs a link. Variable type. Same for function type. Okay, and then we also need bool. And I had a name for this scope get. So check parent scopes is what I will call here. Okay, and if we do check them, then we do check them. Okay. Okay, so here we would do, let's actually just copy paste what I have here, declare variable. So this is it, almost exactly the same. It's just we are working on types instead of values. So get variable type scope, and this will be parser error. Parsers. It looks like we need the parser here. Parser. 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 Run. And here's probably where I would throw an error parser. Expected variable declaration. Right? And then here we say parser name false. And here you want to scope this. We want to do this in the scope arena. Like this. Like this, okay. And now let's just say function type func. Oh, is it true? Yeah, I should have that. So when I assign a function, I don't care. When I declare a function, oh no, when I assign, I do care. When I declare, I don't care. And pretty much, so I always pretty much care unless I'm declaring first. Okay, so let's copy paste this. Okay, right. Expected function declaration. Parent scopes, right? Yeah, I'll make this function type. Okay, and now so here is where we would do get function type, right? Parser scope name true, right? This would be token add. Scope. I could push the name to the function type so that I don't have to push the name each time I have a call, but that's something I can do in a sec. And now what I need here is I need a type scope, right? Scope. That's something I pretty much need in every parser thing. Scope, scope, scope. Okay. Scope arena, right? Does those feel like redundant code because I'm basically doing what runtime is doing anyways? But it's fine. Should probably be called TypeScope though. So let's call this TypeScope and now replace this with TypeScope. And now let's fix every error. Yeah, fixing errors like this should just be like automatic, but it isn't. But you know, then they write AI that write code based on other code, which is like useless for most people. And they won't make an AI that actually is a productivity improvement. So that is pretty sad. Oh yeah, this is not where it's supposed to go. Okay. The unary up is just it has to be run type none, and then when we do this, we would do result type equals child. And result type like this, right? And now this would be result of two types, and this would be left result type and right result type, right? I guess what I should do here is I should propagate it up for let's see, unary equals bottom unary isn't the top, right? I don't actually know though. Okay, that's fine. Unary equals unary link ref, right? It's more like top, and until it isn't the bottom, we do unary up expression, right? Right. That would make sense, I think. Right. Okay. Although that's not actually true because this unary expression actually doesn't. Oh fuck, so I will need to just define another table. It's like basically the same table as the runtime evaluation table, right? Like we have this evaluation table where it's here, right? For binary up. And I guess that means I can then remove the type here. Right. Yeah, I just need to refactor this eventually. That's fine. And then I'd probably have a function that like does runtime value, returns runtime value. It's like parse or evaluate binop or something, and would be runtime value A, runtime value B, and then the operator, which is not this. This is Lex token type, right? So it'd have something like this, and also could do unop. And then we would also have a cast, right? Would have like a runtime value cast, runtime value, a runtime value type. And then we also need runtime type, which is get or unop type maybe, right? Runtime value A. Next token B like this. And then would also have a binop type. Binop type. So let's mark those as to do, right? To do. I'll drop them up here like this. I guess this is for parser, and this is for runtime, or rather like this. To do. Because we would be casting stuff to the results type anyways, and the typing, whole typing would be handled by the parser. There's no reason that we would have to handle typing in the runtime outside of just casting variables, right? So let's leave that there. Okay, and here we just return our actual time, right? And now it's the runtime type. Okay. Okay, so we do just read the type after the function here. So once we have like a const func, so we'll say get end, right? We'll say a end like this. Also have to do this. Right? Return a times 2. Let's move all of this somewhere. Regression test, I guess, and then let's print get end. And now the default value here is just the type. Okay. Let's do this. So push statement scopes. Scopes are meant to not have a type. none. This is runtime type none. Okay. This is a statement, so it should return none. This really is just runtime type any, but oh, I know what it is. It's like to do current function. Get result type of the current function, right? That should do it. Yeah, let's just remove that and break it, continue. We'll never have a runtime type. Same for if. Declare has no type. It's a statement. Yeah. Unassign also has no type. Okay. So here we go. And then parser identifier not found. This means yeah, infer type is no longer a thing. This probably needs to go up. Like maybe here. And this would just be a statement result type like this. And another thing where it inferred the type is here, and here we would just say value result type. Okay. Yeah. Like here. Okay. And now another thing that I need to do is for parameters. Right, we need to expect a token Lexer Lex token type colon parser Lex Lexer and then expected colon after param name, and then we would do param type equals read type parser type scope. Well, let's not do default types yet. Default params yet. Okay. And now we just need to actually push scopes. I wish we didn't have implicit scoping because that's a bit sad. Wait, how do I do this? So you have read scope, right? So anytime I read a scope is when I would want to push a type scope, right? this is push. It's like I would create a new. So I don't think I have that. So I would have static type scope. Make type scope would be parser, and the type scope, right? And this would be like, so the type scope equals. Well, it doesn't necessarily have to be allocated in the arena, right? It can just be here. And this is the parent. Type scope parent equals parent. Type scope marker equals arena marker parser scope arena, right? And then we also make a dispose function, or rather unwind type scope. Type scope, rather type scope. And what we would just do is arena unwind, or rather unwind marker parser scope arena type scope marker. Okay, and we need address of here and here, right? How does this differ from unwinding the runtime? Yeah, it doesn't differ at all. Arena. And that's interesting. So what I had there is I would have an arena here, right? Because then I can do arena parser arena, right? And then this can just do arena like this. And now when I do this, I don't have to pass the parser anymore, right? Oh, I do still need to pass it. That's sad. I need to pass it for the errors. I would rather not though. So I guess that means I just don't bother with starting the arena twice. I think is the lesson here. Okay, so now basically when we wait, this is make runtime arena. I'm sorry, make runtime scope, and then this is make type scope, right? Type scope. Okay. So now when we read scope, right? When we read a scope is when we would push the parser type scope, scope, rather new type scope, right? Would push it here and would unwind type scope here, new type scope, parser, new type scope, and we would pass it here, right? Like this. Okay. So now we have Now we have that, and now what we need is, so with variable declarations, right? Okay, so when we have, so first let's do functions maybe. So here function, and when we parse the function, I would just do like add. It's like declare type, function type, and I would do parser type scope token add, right? Or just do function name, function name, and function result type, right? This is all we need here. I guess we don't have the name here. That's pretty sad. Well, that's fine, because that just means we static void declare type parser type scope and statement declare, right? This is all we need, and now we just give it here type scope declare, and we do the same thing when we are declaring here, right? And now if declare type declare it would be, well, we need the name, right? We need the value result type, right? And now if the value, if the type of the value is runtime type function, then we do this. I guess if the runtime type none, then we parser error attempt to assign a value of no type return, right? And now if this is a variable, instead we declare a variable type. That's pretty much the same. It's just a different thing. That sort of makes me think that this, like, because we have four data structures, separate data structures that are all pretty much the same. They just differ with the type, right? So this is like where we would want to use like templates or generics, but just the C++ templates are so bad, I'm not gonna bother. But it would be nice to cut the amount of code here, I think. I will think about it, but it's not that important, I don't think. Okay, let's see. See what we got. Return type, variable type is no. Right, so there is a time we do this, and otherwise we say runtime type none, and that should catch some problems, I think. And then the same thing I would do here, function type function runtime type none. And I guess what I should do here is if function type, we should have a parser error. Parser accessing not declared not accessing a not declared function. And I will do the same here. Let's say not declared variable. And I think what this actually just is the fact that we don't deal with params correctly yet, right? So when there's a function call, right? We should make a type scope, right? Function call. So we would get the function type. I guess function literal function. So I want to store this here. Function type, right? Function literal right. Let's grab this here. Oh no, never mind. This is the wrong func. I want this in declare, not in the get. Get is supposed to get it. Okay, function. No, function equals function. Okay. So yeah, this would be the function literal, which has all the params. Okay. And now when we do function call, is where we have to like function call. So we would say parameter, right? Param equals function call function params first, right? And now we would want this. If param or if no param or param type isn't equal arg type, arg statement result type, we'll say parser error incorrect parameter type and argument type, and we'll say parser here. And otherwise we just say param equals param link next, right? Oh no, this is meant to be function. What? Function type function params first. Okay. So function call has args, yes. Param. Okay. Oh, I should always just have access to this, right? I think. And then we don't. Interesting. So I'll say this for now, but I will have to remove those later. And yeah, I think that's fine, but then in the function, in the actual function, right? The function, when we actually push a statement function, right? So for this scope, we actually want to create a type scope. Type scope, new type scope equals make type scope. Parser type scope, and we would want to unwind type scope, parser type scope after reading the scope. And now here we would want to, so let's actually move this here. And we would want to, here we would want to declare variable type and then new scope, new parser, new type scope, parser. In the new type scope, we just want the param name and param type, right? Okay. I just hope that params are not actually variables because that would be AIDS. Yeah. I guess what if param is a func? Say to do. Okay, do we still crash? We do. Oh, I see. So this checks if the function type is still null, which means declare function type failed. Expected variable accessing a not variable function. Not variable function. This is weird. Not declared variable. So this problem is this early, interestingly enough. Why does it think that? Oh, it's because parser is still. So in the error of the parser, we probably want to use the current instead, and same for the lexer. Yeah. Interesting. Hmm. I had the window only after the test, which is a bit weird. Okay. So we have problems here. And it feels like what's happening is basically declare. Are we in the correct file now? Particle. Wait, what? Declare type right here. Let's run this. Let's see what's happening. Yeah, this type is just wrong. Oh. Oh, that's dumb. I see. Okay, so basically this is wrong. Interesting. So this needs to be runtime type. Right. Oh. Interesting. I think what I need here is just this, right? Declare value type. Alright. Well, I already wait one. Yeah, this is a problem. One. Is this dumb? Okay, let's so I know what's happening. It's because the oh god damn. And that should be fine. We just and when we declare a function, right? Statement function here. I see. Okay. So we have not pushed the correct scope, nor have we unwinded the correct one. Okay. And that's why we have the errors. So this is expected function declaration, right? Right. I guess let's not another route here because we are just redundant. Not declared function. Oh, that's weird. So let's see. Let's have one here and one. Let's have declare type, right? I wish I started with types because a lot of things would be easier now. Fine, that's fine. So we are where exactly? Yeah, we are here. And now, even though the type is indeed function, it goes to variable. What? What is wrong with this? Why? So in the read assignment expression, right? We just get return statement type function. Statement function. Oh, I see. I see. I know what it is. It's because I'm actually incorrectly. I'm using the incorrect enum. So declare type, right? Because type is not, it's a statement. Yeah, here. This is a statement type function, right? Function. Okay. Should not have an issue anymore. B float. Expected semicolon after expression assignment. Seems incorrect. Let's print our stuff if we can. Print. Do we print? We do print. Interesting. So let's see. Parser. So is it because we do something weird? Oh. What? Alright, okay. So this should just work. I see. Interesting. Retype. So let's move our B. Oh, actually, this is just a missing semicolon. That is what makes it really annoying because like pref and current token are sometimes very different. So whatever. Expected semicolon. Yeah, okay. So this one, this ABC thing just needs to have types, right? No, this is fine. I want to type any though. Like interesting. Const func. Do we get a 4 printed? Oh no, we just have errors. Error. So that's weird. The syntax is correct, right? Let's see. So it says expecting. It's doing something weird here, I think. Assignment expression, right? Here. Oh. Also. I see. Okay. So what we basically have missed is copying this here. Attempt to assign a value of no type. Huh? We don't know. Let's see. This, right? This is the problem. Okay, so let's get this done. Really? Huh. Yeah, also I think when I named the thing, so rename this to runtime type, I think results type is better. More accurate. Wait, why is this all so junk? Yeah, I think what I will do though is like in parser I will just keep a bool hat errors in. And then on parser error I would say parser hat errors was true. And then if parser had errors, then we return nothing. At that point, we basically free arena script arena, right? So we dispose of the thing. Yeah, this would be an empty script. Parser error. Attempt to assign a value of no type. Yeah, I wish wine was so bad. Yeah, I hope I'll be able to simplify a lot of this code because it's starting to get pretty messy. Is another thing I could have is warnings, but I don't know. It's needed. So yeah, somewhere here there's a problem. Let's try bugging this. Okay. Oh, actually, this is the first one. Really? So wait, what is the name? Name is get int. Good. And then statement expression. No, but function calls shouldn't be a problem, right? Function call. This is a value of type integer 2, right? Okay, so I don't think this is the problem is actually here though. I think it's here. Right. Okay, and then this another time would be the problem. Okay, so the first one we just skip and then we go, let's see. So the name is A. Okay. Maybe it would make more sense if I did this though. So name is A, right? And then type is integer. Okay. So this is still correct. And we declare the type. And then we consume the comma, right? Does pop the token, cool. And then now the identifier is B, right? We push the name, we do the type. Type is integer, that's correct, cool. Seems all correct. Okay, so the function header was parsed exactly like it should be. And now the question is, no, the scope is not a source of errors. No errors yet. It's actually super weird. Oh, but then the close brace of the scope. So it seems like the close brace of the scope. While true. Okay. So if there isn't a statement, we would expect token expect token parser lex token type close brace expected close brace on the end of scope. Right. So if there isn't a statement, we expect the close brace and we want to exit. And if there is a statement, we add it and we check if there's a brace. So maybe instead what we do is just we accept the brace, and otherwise, I guess parser error expected a statement. Before or an end of scope, right? Right? Well, this function doesn't look complicated at all. I don't know what's the problem with it. Let's see. Statement type function. So here, right? So first one is whatever, the second one is where the problem is. Okay, now Lexer current is identifier end, right? And then it's the close parent. Wait, what? Okay, there's a problem with this. No, there isn't a problem. What? No, there shouldn't be a problem. So close parent here. So current. Okay, yeah. So now it goes here. The token is open brace. Yeah, okay, that's correct. We push a new type scope. Right. Just have a statement and it does accept a close brace. What does peak do again? Peak accesses the next, right? Parser, Lexer, next. Right. Hmm. Oh yeah, that's the problem. So functions then have to have a return type. That's fine. Yeah. Okay. That makes more sense. Oh, I closed something. Yeah, Elixir. Right. Holy fuck. Okay. Do we work now? Missing matching close parentheses. This is in function call. Missing matching close parentheses. Interesting. Hmm. Why would this be? Okay, I think this one is like a similar kind of problem where it doesn't. Where I have this like 2 segment loop, which really should be at the while, but I can't make it at the while because the first one doesn't accept a token, right? I mean, in this case, I guess I could, right? It's not really, because the first one is like completely optional, right? Huh. Well, I could make it a while true loop with breaks, and that could work. I don't know. But I'm not convinced this actually fixes the issue though. Missing matching close parentheses. This is weird because it thinks that the open parent of the function is part of the expression, right? That's the strange part. Because here, if we just look at the name, I think it is correct, right? Right. Read primary. And now this token is an integer. Oh, wow, we won. Oh, maybe what's happening here because what? This expression is of kind value and it is integer too. So if we look at the AI test, we are exactly at this point, right? Well, I don't know why I'm even testing this because this one is actually correct, I think. Right? Yeah, it's the const find that doesn't work. And it seems like it's not even a function call, which is the reason it breaks. Const find. Why would it think it's an open parent? Right. Read statement. Interesting. So I guess what this tells me is that actually what happens here is this const func here gets eaten. That will make sense, right? Because then, so let's see. Can I just, so let's move those up again. Let's do this. Get the same error, but this time when I do read scope, I guess another thing I would need to is like do. I probably can move this here as its own scope, right? Right. Okay. So now when I read a scope here, right, I can check what I'm doing. Just check what the next token is. Read a statement. It should be a statement of type print. Right. Have I made identifier? So identifier statements. Those are just assign and declares, right? Okay. I think now it's technically possible to use. It's funny. It's technically possible to use variables and functions of the same name because they are like different namespaces now. Something that should be corrected, I think, since it would be very confusing. Okay, so now it accepts a brace, right? Now the next thing to go is the const func and what happens to it. Okay, we unwind this. We go back here. It does what it's supposed to do, right? Right. Okay, so that's to the list of statements. Now we come here and what happens? Then get a control flow. We shouldn't get this, I don't think. Oh. Really? Really? Okay, so this is just where we have to say parser, save state, parser, parser, store state, parser, right? And then here on the else, we do parser, restore state, parser state. Just like that. State like this, okay? And this actually would be Lexer. Accept non-reserved identifier Lexer identifier. That should do it, right? Okay. Lexer, or rather, parcel Lexer. Okay. That should do it. So basically, identifier statements were eating the token. That's why the function call broke. I think now we should be in the clear. Okay. And now actually what I want to do in the runtime is I want to separate those two loops because I would want the full AST first and then I guess I would print f something like this, right? Probably something like this, right? Okay. Can assign to a non-declared variable? Okay. So another thing I wanted to do is call stack tracking. But I don't know. I don't know how to do it on this yet. Because runtime errors are currently very useless. They don't tell you anything about where the error actually happens. Hello 123 can't assign to a non-declared variable. I think that just means that AI runtime can't assign to a non-declared variable is because so we broke reassignment to functions, I guess. Declare type, right? So when we assign value type runtime type push okay, so name is pretty important here. I keep switching through lists, not even realizing. Strong habit. Okay, so this is hello, right? And then the values of type function. Function, right? Param scope. Scope is null though, which is weird, but
Well, I guess I'm not surprised if the scope is completely not there. Okay, so when we do read assignment expression, so do open paren. I guess what I should call this is read function expression, and this identifier thing we read assignment statement, right? Function expression, right? Okay. Now when I, so this is hello, right? We have open paren. We accept some stuff, and we go here. We go here, right? Okay. But then getting the scope fails somehow. It seemed like. So we do a scope, accept. There's no close brace, which means. Oh, what? Restart. So we go to the scope part, right? We go through statement, add to the statement, we go have the brace. Don't really see a problem if done. Hmm. So it seems like it's all correct, interestingly enough. So we have some params, right, and then the function, scope. This is a scope. And it has exactly one statement, right? Oh, I know what it is. So, the result type of this. No, sign doesn't need a result type. What the fuck? Maybe function. I'm so confused. Sign variable. Oh. XD. Is this it? Is this just it? Of course it is. Okay. Does make some sense. Okay, so let's quickly, before I go, let's quickly add some new things. So what I want is basically all of those, but as a version of assignment, right? So let's say assign add, right? So now okay. If C1 equals this, we should select this whole thing. And we should paste it here, right? We else it like this, and now here we would do 2, and here okay, and here we just type assign. Colon is not something I wanted to change. Assign modulo, assign divide, assign multiply, assign subtract, assign add, right? Right, okay. Good, it tells me. So those would have a signed version. So now those are just statements, right? So like we had binary up, we'll just have identifier up. Let's leave this to do because it is involved, but let's see. So let's grab what we have on AI parser at the top of the file, right? So and so I added the Lexer support for assign identifiers, assign tokens, I mean. So that's neat. And now all I need here is, so those things, this we actually have supported, so this is done. This is EAP, okay. And then this is a to do. This is VIP, this is done. This is to do. Support for assign ops. Assign identifier ops, like else equals minus equals support for unary identifier ops, like 3 plus prefix, suffix, right? Let's do this. Let's move all this here, right? And let's do this is like introduce type results type concept to AST. And then add casting, add implicit casting, and explicit casting, and refactor operations eval type code. And this is in progress. And this is also in progress. Okay, so this is the to do here. Okay. And like a big thing later is consider using bytecode for performance. How to use bytecode via bytecode. How to generate and run bytecode for better performance. Okay, this is it. I'll just push what I have today. And what else did we do today? Yeah, just add types into the syntax. Okay. That should be it for today. Now, obviously, the whole concept of result type is so we don't have to resolve types at runtime. It's so hi. I was about to finish, so where did you see podcast? Anyways, the whole point of having result type is so we can resolve all the type stuff at parsing time, so we can know about all the errors, and also so we are basically faster at runtime because we don't have to like try to like be JavaScript where we like allow any type be anything. Although I do plan to have type any probably because that might still be useful for some stuff. And then I guess one thing I should let me note those. Add type any. Oh. It's funny. So we want to add type any and we want to there was some type related thing that I didn't note yet. Yes, I'll just note this here, using result type. Yeah, okay. So that's it. Too bad nobody was here when I was actually still working, but whatever. I still did the work, so that's useful. And yeah, I'll see you in an hour probably. So